Imagine a production line that has been running perfectly for months. Suddenly, a warning light flashes and the entire system stops. Efficient manufacturing relies on prevention. Instead of simply reacting to broken parts, engineers look for ways to identify a defect before the product ever leaves the factory. To achieve this, world-class teams use a specific framework called the 7 Basic Quality Tools. These are the primary methods used to track down and resolve even the most complex manufacturing failures. Solving an engineering problem requires more than a lucky guess. Success comes from translating the chaos of a factory floor into clear, visual data that points toward a solution. Consider a common scenario. A smartwatch factory sees 50 units fail quality checks every single day. To fix this, we need to move past assumptions and start gathering raw data. We start with our first tool, the check sheet. This provides a structured way to record observations in real time, ensuring we have a set of hard facts to look at later. As inspectors examine the watches, they record every failure into specific categories, such as scratches, dents, or software errors. Over a week, these simple tally marks create a clear map of our problem. Now we have a list of several different defects. Since we can't fix everything at once, we use tool number 2, the Pareto Chart, to help the team decide where to focus their energy first. This chart is based on the Pareto principle, or the 80-20 rule. It shows that roughly 80% of your problems are usually caused by just 20% of the possible causes. Here, the data shows that scratches are our most frequent failure by a wide margin. By identifying and fixing that single tallest bar, an engineer can eliminate the vast majority of product failures in one move. Identifying scratches as the main problem is only the beginning. Now we need to understand exactly what is causing them. Tool number 3 is the Fishbone diagram. It helps a team brainstorm by mapping out the potential chain of events leading to a failure, rather than just looking at the final result. We organize our ideas into 6 categories, often called the 6 M's because they each start with that letter. These are manpower, machine, material, method, measurement, and Mother Nature, which covers the environment. While brainstorming the machine category, we decide to check if the speed of the assembly line is inconsistent. To analyze this, we use tool number 4, the histogram. This graph plots how often the machine runs at various speeds. When we see the data form this rounded shape, it tells us that our machine speed is actually quite stable and consistent. However, while the speed is stable, we notice that the machine is generating a lot of heat when it runs. This leads us to wonder if the equipment's temperature, not the speed, is what's causing the scratches. To find out if this temperature theory is correct, we need to see if these 2 factors are actually linked. We do this with tool number 5, the scatter diagram. This tool allows us to mathematically see if a change in one variable causes a change in another. We plot temperature on the bottom and the number of scratches on the side. As the dots form a line sloping upward, we have our proof. As the machine gets hotter, the number of scratches increases. Now that we've adjusted the machine's cooling system, we need a way to ensure the process stays safe in the future. For this, we use tool number 6, the control chart. This chart sets a target center line and 2 boundary lines called control limits. As we track data daily, we see if the process stays within safe boundaries. If a data point jumps outside those lines, it acts like an early warning radar, letting us fix the issue before a single defective watch is made. Our process is fixed and protected. To make sure every team member knows exactly how to maintain these results, we need to standardize the work. Tool number 7 is the flowchart. It provides a visual map of the entire process, including the specific steps to take and the decisions that need to be made at each stage. This clear visual standard ensures that the improvements we've made are followed correctly every time, preventing old errors from returning. These are your 7 tools for quality improvement: the check sheet, Pareto chart, Fishbone diagram, histogram, scatter diagram, control chart, and flow chart. By using them together, we can collect facts, prioritize the biggest problems, find the root cause, understand variation, prove connections, monitor results, and standardize the work. Mastering these visual tools allows you to turn raw, complicated data into a clear plan for improvement, which is a vital skill for any successful engineering career. Which of these 7 tools have you found most useful in your own work? Let us know in the comments below. If this video helped you understand the fundamentals of quality control, please like and subscribe. For a deep dive series on each of these tools, just comment Quality Series below. Thanks for watching.